Before we get to the shortcuts for graphing functions that are not linear, I want to talk about the quadratic function. So a quadratic function is a function that's in the form of y equals x squared. It's a function with an exponent of 2. So that exponent of 2 is what makes it a quadratic function. So I want to explore with what a quadratic function looks like with a t-chart. So over on the left here, I've got y equals x squared, and we're going to plug all those numbers in for x, which just simply means we're squaring each one of those numbers. So 3 to the second power of 3 squared is 9, 2 squared is 4, 1 squared is 1, 0 squared is 0, negative 1 squared, so that means negative 1 times negative 1, and that's actually positive 1. So negative 2 squared is positive 4, and negative 3 squared is positive 9. And then I graph each one of those. So 3, 9 would be to the right 3 and up 9. That places it here. 2, 4, 1, 1, 0, 0, negative 1, 1, negative 2, 4, and negative 3, 9. So when you draw this shape, it actually makes a U shape with a rounded bottom. So I'll draw the best U that I can. It's not a sharp corner in the bottom like the absolute value function that was the V shape. It should be a rounded bottom. And the reason it's a rounded bottom is because what is going on with all those little tiny fractions and decimals between negative 1 and positive 1. Say, for example, that I were to use 1/2 as one of my points in a t-chart. 1/2 squared is 1/4, because 1/2 times 1/2 is 1/4. So you would have to go over a half, but only up 1/4 of a unit, which would place it about right there. It's not like with the absolute value function. The absolute value of a half is a half, and it would be in a straight line between the 1 and the 0 here, and the 1 be a straight line, which is why it's not a sharp corner down there, and that's why it's a rounded rounded vertex at the bottom of that U shape. The domain, it is all real numbers. And the range, notice that it goes only down to 0, and then everything else is above it, so it'd be y greater than or equal to 0. Graphing a quadratic function is usually a little more difficult than graphing your absolute value functions because of the location of these other points. Because notice the higher we go up, the farther these points get from each other. So what is a quick way to get those points located? And the answer to that revolves around the pattern that is created by the numbers in those points. So down here I have 0, 1, 4, 9, 16. What is the way to describe that pattern? Let's say back we were in geometry or in Algebra 1 or even in junior high math, and the question was, what is the next term in the sequence? How would you describe the pattern, and then what would be the next term in the sequence? There's actually two ways to describe that pattern. One way that many students remember is that they see that I'm adding the next odd number between each terms in the sequence. So 0 plus 1 is 1. And then 1 plus 3, that's the next odd number, is 4. So 4 plus 5 is 9. And then 9 plus 7 is 16. So I'm adding the next highest odd number. But there's actually another way to describe that pattern. It's because 0, 1, 4, 9, 16 are all perfect squares. 0 is the same as 0 squared. 1 equals 1 squared. 4 is 2 squared. 9 is 3 squared, and 16 is 4 squared. So no matter what pattern we follow, we're going to come up with the same number. So the next term in the sequence would be 5 squared, which would be 25. And that also follows adding the next highest odd number, which would be 9, to 16, which would be 25. So either way to describe the pattern works. So knowing that, we can come across a quick and easy rule to figure out where the next points are located. This is not a rule that you're going to find in any textbook. You're going to find it probably on the internet, obviously finding it in this video. So I simply just call it the 1, 3, 5 rule. What the 1, 3, 5 rule is, and it's not rules, it's rule. There we go. The 1, 3, 5 rule. What the 1, 3, 5 rule is that starting at the bottom of the graph, starting at the vertex, I can find my next set of points by going out 1 and then up 1 unit. So out 1 and then up 1 unit on both sides. And then I can, from that point, I can go out 1 and then up 3 units. So plus 3, and then out 1 and up 3 units. And then from these points, I could go out 1 and up 5 units. 1, 2, 3, 4, 5. And out 1, 1, 2, 3, 4, 5, plus 5. So that's why it's just simply called the 1, 3, 5 rule. It works. The proof is down there, how the next highest odd number is related to perfect squares. And so feel free to apply that when you're graphing these U shapes. On your previous set of notes, and I'm going to reference the previous set of notes from the last section quite a bit, from section 2.5, we had a graph that looked like that. It was y equals the absolute value of x minus 2, and this is actually the previous set of notes is right over here. So right here was the previous set of notes. So up here is y equals this absolute value of x minus 2. And you did a t-chart for it, and you can see in the blue that's what the t-chart looked like, and then you graphed it. And then I asked, could you have predicted that it was going to be 2 lower than the regular absolute value parent function? And yes, it is possible. A lot of students would say yes, because I see that minus 2, which means that the vertex and the rest of the points are going to be 2 lower than the parent function. This is actually one of the shortcuts. It's called the vertical shift. In geometry, you may have heard the shift referred to as another word, a slide. Algebra 2, they call it a shift. Geometry, they call it the slide. It's really the same concept, is that you're taking a graph and you're moving it in some direction, just like you could take a geometric shape and move it in some direction. So, whenever the number being added or subtracted is not grouped with the x. So notice that if you look at the equation, that minus 2 is not grouped with the x. Since it's not grouped with the x, it is going to be a vertical shift. So when it's not grouped with the x, that is going to be a vertical movement. So a vertical shift. So you have your standard parent function, which is y equals absolute value of x, which is, I'm going to go ahead and draw that parent function in there. It looks like this, so it's in black. You know, we did this in the last set of notes. But now every one of those points, including the vertex, gets shifted down 2 units, and then we will make the rest of our points to make our V shape. Okay? So I want to do another one. So let's do in green here another function. Let's do y equals the absolute value of x plus 2. So I'll graph that on the same graph. So again, the black is the parent function. That's the basic absolute value graph. Since it's absolute value of x plus 2, and that plus 2 is not grouped with the x, that means we're going to take the vertex and we're going to move it up 2 units, place it right there. And then to draw the rest of our V shape, we'll just go up 1 over 1 both directions. And the green is the function y equals the absolute value of x plus 2. Done very quickly, t-chart not needed. And you can do many, many more problems than this on an assignment than to try to do a t-chart each time. So let's do a couple of others. Let's look at example 1. It says describe the translation of each function as it relates to the parent graph, then graph the function. So it's y equals the absolute value of x plus 2. So let's do that one again. I got through just doing it, but let's do it again without seeing the parent function on the graph. So normally the vertex of the parent function is located right at the origin, but since we have a plus 2 outside of the grouping symbols, it is not grouped with the x. That means it is a vertical shift up 2 units. So I'm going to take that vertex and I'm going to go up 2 units, place it there, and then since I know it's an absolute value function, it creates a V shape. I will throw a couple of extra points in here on either side so I can make a nice, crisp, sharp, cornered V shape. And that's what your graph looks like. Part B is y equals x squared minus 7. So that minus 7 is also not grouped with the x. Okay, it is off to the side, it is off behind it. So that means it is also another vertical shift, and that is going to be vertical shift down 7 units. So from the origin, I'm going to count down 7 units. And this is where the vertex of my graph is going to be. However, what's a little bit different on this one is that it's not absolute value. It's got that exponent of 2 in there. And that exponent of 2 means that it is a quadratic equation, which means it is going to be a U shape. So we're going to apply the 1, 3, 5 rule to get the other points in the graph. So again, from the vertex point, I'm going to go out 1 both directions and then up 1. So the up 1 is the one part of the 1, 3, 5 rule. From those 2 points, from the 2 points I just drew, I will go out 1 more and then up 3 on both sides. So out 1 and up 1, 2, 3 on both sides. And that is the 3 part of the 1, 3, 5 rule. And then now go out 1 and up 1, 2, 3, 4, 5. Then out 1, up 1, 2, 3, 4, 5. And that is the 5 part of the 1, 3, 5 rule. And then I'll draw my best rounded U shape through there. And there you go. There's your parabola shifted down 7 units. Parabola is what we call a U shape in Algebra 2. We get more into that when we get to Chapter 3.